Now we are going to solve the third problem in laws of motion chapter. So in this problem, a spanner is given. Okay, the length of the spanner is given as 40 centimeter. You know the purpose of using the spanner. With the help of the spanner, the nuts that can be screwed or it can be unscrewed. Bolt and nut both can be unscrewed and screwed. Here some amount of force is acting. As per the problem, 140 Newton amount of force is acting here. And the length of the perpendicular length value is how much? 40 centimeter. When you apply the force here, what will happen? The torque, that moment of force will act. The torque, that one will cause the turning effect. Because of the turning effect, the nut that can be unscrewed. Are you clear? The unscrewing process, that one takes place because of the turning effect. The turning effect is provided by the torque. Are you clear? So here we can calculate the torque. Let's see the second case. What you have to find out, that is a question here. Here, same amount of torque it has to act here, but the amount of force applied here 40 Newton. Are you clear? Previously 140 Newton amount of force was acting. Now the force value is being reduced. But by using the spanner, we have to get the same amount of torque. Same unscrewing process has to be done by the torque. So to get the same torque, what should be the new length of the spanner? What should be the new length of the spanner? That is the question. Here force value is reduced. Are you clear? But you have to get the same torque. With the help of the same torque, the same unscrewing process has to be done. You are asked to calculate the new length of the spanner. How to start with? In both the two cases, torque value is same. Are you clear? So torque acting on the first case and torque acting on the second case, both of them are similar. Therefore, first I will calculate torque acting in the first case. Torque acting in the first case to be calculated, that can be taken as τ1, force into perpendicular distance. Therefore, F1 into L1. What is the formula to calculate the torque? Force into perpendicular distance, F1 into L1. Here F1 value is 140 Newton into length of the first spanner is how much? 40 centimeter. Multiply both, you will get 5600 Newton centimeter. Just for convenience, I didn't convert the value of centimeter into which one? Meter. Are you clear? So this is the torque acting in the first case, that is the first spanner. Now what we have done? Now we are using the second spanner. Are you clear? But the same torque has to be applied there, but here the amount of force is reduced. Torque acting on the second case. Torque acting in the second case is τ2. What is the formula? For F2 into L2. This is the new length of the spanner to be found out. Substitute now F2. We know the value of F2, how much? 40 Newton. But which one is unknown? L2 is unknown. Here, as I have told earlier, torque acting in the first case, the torque acting in the second case, both are same. Therefore, τ1 is equal to τ2. We can write it like this. Substitute the values now. That is, τ1 value is 5600 Newton centimeter is equal to τ2 is equal to 40 Newton into L2. Which one is unknown? L2 is unknown. Therefore, L2 is equal to 5600 Newton centimeter whole divided by 40 Newton can be written. Newton can be cancelled. So finally, after cancellation, you will get, look at the value of the length of the spanner. The value of the length of the spanner is 140 centimeter. 140 centimeter. Look at that. Because of the reduction of the force, to get the same torque, we are in a position to increase the length of the spanner. So you have to use a lengthy spanner of length, how much? 140 centimeter to get the same torque. Now you